Let's go on now to our first example now with tangent, which is we're going to go ahead and sketch the graph of y equals 3 tangent of a fourth x by hand. All right, and as you can see here, I've already written down our critical or our key points for tangent. We derived that in the introduction video to tangent, and you need to have those memorized. And but if you don't have to memorize, you can just derive them, right? I mean, just go to negative pi over 2 and then just take the tangent of that. So, but the more you do these, you're just gonna know them, by heart. Just like like your mom's phone number by heart. Like, oh yeah, I know you're by heart. Okay, anyways, not that I'm talking about anybody's mom here, but okay. This is gonna follow the same process as we did with sine and cosine, where what we want to do is that we want to set this guy right here equal to theta. So like 1/4 x equals theta. Because when I graph this, okay, like over here, this is going to be my x, and then my y term is 3 tangents of a fourth x, right? So we always set what's inside the parentheses equal to theta, and I want these two to be the same value. So the way that I'm going to get my new x values is I had to set theta equal to x. So now let's go ahead and solve. Well, if I want to get x by itself, I'm just going to multiply both sides by 4. And so x equals 4 theta. Well, that one's kind of nice because all I got to do then is just multiply all these guys by 4. So if I multiply negative pi over 2 times 4, that's negative 4 pi over 2, or just negative 2 pi. Multiply that by 4 pi, and that's just going to give us negative pi. Multiply that by 4 pi. I'm sorry, 4 times 0, which is going to give us 0. Pi over 4 times 4 is just going to give us pi, and pi over 2 times 4 is going to give us 2 pi. So this is very nice over here. So basically that just took care of this whole thing, tangent of 1/4 x. Okay. So now what about this 3? Well, just like we did with the sine and cosine, we multiply now these tangent values, our y values, by 3. So an undefined value times 3 is just still undefined. Negative 1 times 3, negative 3. 0 times 3, 0. 1 times 3 is 3. And the undefined value times 3 is undefined. And there we go. Here are our 5 key points. Let's go ahead and graph this guy. Make a little cool table here. Let's see, I'll kind of make it long. Go like that. All right, so here's our points. And let's see, so we're going to start with negative pi, negative 2 pi, so negative 2 pi, negative pi, and then it goes to pi, and then right here it goes to 2 pi. Okay, well, let's just start with our 2 vertical asymptotes at negative 2 pi and at 2 pi. Okay, so I'm going to go ahead and put my vertical asymptotes right there. So there's that dude, and there's that dude. All right. Negative pi, negative 3. So let's see, 1, 2, 3, and a 1, and a 2, and a 3. So negative pi and negative 3. There we go. 0, 0. And pi 3. Pi 3. Okay. So, and the way that, okay, like even though that this looks like it's a straight line, it's supposed to have a kind of what we call a point of inflection. It has to have the curviness there. So just, try to be cognitive of that. So it should kind of ride along this, and then it kind of comes up, and then it kind of comes up right there. So I know I could do a better job on this, sketch pad here, but okay, so this is what we call one period, right? We've done one full period from negative 2 pi to 2 pi. And actually this raises the question, what's the period of this function? Well, the period is going to be 4 pi. The period again means how long does it take to graph one full cycle? Well, it went from negative 2 pi to 2 pi, so the entire length of this is 4 pi. Okay, but one period is not enough. Okay, we always want to graph at least 2, but even 3 sometimes. I think, for the tangent, it's always nice to graph 3 of these. So actually what I'm going to do is that, I'm going to expand this to the right and to the left, and it's just a mirror image. There isn't a lot of thinking involved. You just kind of have to do, well, pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. Notice how I went up to 6 pi, because if a period is 4 pi, well, that means I have to add 4 pi to this. 1, 2, 3, 4. And so I know right here at 6 pi, there's going to be a vertical asymptote. All right, and I'm going to go over here as well. 1, 2, 3, 4. Negative 3 pi, negative 4 pi, negative 5 pi, and negative 6 pi. All right, put my vertical asymptotes in. Okay, but all that's really necessary is just going to be 2 periods, but I just want to make 3 right here to make it nice and complete. And see, so that goes there. 1, 2, 3, and 1, 2, 3. So let's see if I could do a much better job this time. So I'm going to go like this and like that. Okay, maybe that looks just a teeny bit better. I don't know, not really though. Oh well, you guys get the point. Wish I could do it better on this little sketch thing, but like that and like that. Hey, that's not too bad. I don't know, actually, that's just my opinion. Oh, okay, that sucks right there. Okay. So basically, just, graphing either of those 2 right there would have been fine, or graphing those 2. So really, you only need 2 periods, but never less than 2 periods for a full tangent graph.